Okay, we need to find the antiderivative of x times e to the x. The question asks us to use integration by parts, so that's exactly what we'll do. Integration by parts is the right tool here because we have a product of two different kinds of functions, a polynomial, x, and an exponential, e to the x. And there's no simple substitution that untangles them. Let me write down the integration by parts formula. The integral of u dv equals u times v minus the integral of v du. The whole game is choosing which piece is u and which is dv. A handy guide is to let u be the part that gets simpler when you differentiate it. So I'll let u be x because its derivative is just 1, nice and simple. And dv is the rest, e to the x dx. Now I differentiate u to get du. The derivative of x is 1, so du equals dx. And I integrate dv to get v. The integral of e to the x is just e to the x itself, which is what makes the exponential so friendly here. Now I plug everything into the formula. U times v is x times e to the x. And then we subtract the integral of v du, which is the integral of e to the x dx. Notice the new integral is much simpler than what we started with. That's the sign integration by parts worked in our favor. The integral of e to the x is again e to the x, so we subtract that off. Since this is an indefinite integral, don't forget the constant of integration, c. I can also factor out e to the x to tidy it up. So there's our answer. The integral of x e to the x is e to the x times x minus 1 plus c. You could differentiate it to check, and it comes right back to x e to the x. Here's the final result, cleanly.